Today's lesson, graphing velocity. Here's our objectives. Let's do a little review. What's happening here? This object travels 10 meters in 5 seconds, giving it a velocity of plus 2 meters per second north. Then it travels negative 20 meters in 5 seconds, giving it a velocity of negative 4 meters per second south. But what if we change things up a bit? Describing motion using a velocity time graph is very different. Now it's really important that we read the units. Let's carefully state what we see happening. An object begins at 0 meters per second and then increases its speed to 10 meters per second north. Then the object slows down from 10 meters per second north back to 0 meters per second. Please notice it is slowing down but still going north in this section of the graph. What happens when an object crosses 0 meters per second? Crossing this center line means the object has changed direction. The object is now going from 0 meters per second to 10 meters per second south. It's now speeding up, but it's going south. This position time graph shows an object that moves north, stops, and then goes south. How would this object's motion be represented on a velocity time graph? Let's calculate the velocity at each section. In blue, it starts at 0 and goes to 5 meters in 4 seconds, giving it a velocity of 1.25 meters per second north, shown like this on a velocity time graph. Next, at green, it starts at 5 and stays at 5 meters for 4 seconds, giving a velocity of 0 meters per second, shown like this. And red starts at 5 and goes to negative 4 meters in 4 seconds, giving it a velocity of negative 3 meters per second south. These graphs show the position and velocity for one object in motion. Try to remember this. The position time graph is like a map. It tells you where it's at. This is your location. The velocity time graph is like a speedometer. It shows how fast it's going. Now we'd like to measure the object's displacement. Looking at the position time graph, it's easy to see the displacement is negative 4 meters. Look at the start and end point. Let's use the velocity time graph to confirm our answer. The object travels 1.25 meters per second for 4 seconds, giving a displacement of 5 meters north, plus 0 meters per second for 4 seconds, giving a displacement of 0, and negative 3 meters per second for 3 seconds, giving a displacement of negative 9 meters south. This means the total displacement is negative 4 meters south, and that does confirm our answer. Now we'll use this graph for the displacement of a dog. In the first half, the dog travels at 5 meters per second for 5 seconds, giving it a displacement of 25 meters. But what about the time from 5 to 10 seconds? The puppy is going 5 meters per second initially, but slows down to 0 meters per second. So how can we measure its displacement if it's not moving at a constant speed? We'll need to use the average velocity. The equation for average velocity is distance equals 1/2 the final velocity plus the initial velocity times time. So this displacement is 1/2 of 0 plus 5 meters per second times 5 seconds, giving it a 12.5 meter displacement. So 25 meters in the first half and 12.5 meters in the second half. The total displacement is 37.5 meters in a positive direction. You'll notice the direction is not given, so it could be north, up, east, or right.